This is Mr. Beck Does Your Homework. This is AP Physics, Homework 5.3, question number 1. In introductory physics laboratories, a typical Cavendish balance for measuring the gravitational constant g uses lead spheres of masses 2.28 kilograms and 17.3 grams, whose centers are separated by 4.25 centimeters. Grams, centimeters. Calculate the gravitational force between these spheres, treating each as a point mass located at the center of the sphere. The value of the gravitational constant is. So a Cavendish balance has a thin thread, and it has these little spheres, and they are near the large spheres. So there's one back there, and there's one up here. So there's a force between these two, attractive. And there's a force between these two, attractive. And this causes this string to spin just a little bit this way. Then they move the large masses to the other side so that the force is the other way and the spin is the other way. And what you wind up is, from the difference in that spin, you can tell just how much it's spun and what the force must be. So this was a way that Cavendish figured out the universal gravitational constant. So what we have is two masses whose centers are separated. So I know that the force of universal gravity is going to be the universal gravitational constant times the amount of the first mass times the amount of the second mass divided by the distance between them squared. So that is going to be 6.67259 times 10 to the minus 11. That's my big G. My first mass is 2.28 kilograms. And my second mass is 17.3 grams. So let's see, 17.3 grams. To get to kilograms, that's going to be a factor of three decimal places. So that's going to be 0.0173 kilograms. And the distance is 4.25 centimeters, so I'm going to divide that by, let's see, 4.25 centimeters, that's a factor of 100, so 4.25, bump, bump, 2 decimal places, becomes 0.0425 squared. And that will give me the gravitational force between those two spheres.